All right, I'll give like another 4 minutes or so for the warm up. And so you can do the warm up in browser or in Node, your choice. All right. Hope everybody's doing good this morning. Sorry we can't be in person. I'm at a cabin east of Tulsa on a river. So, all right. So, okay. So this is pretty short, though maybe not simple warm up. So we've got an array of numbers here. And then what I want to do is just have the even numbers in this new variable here. And so I'm doing numbers, not filters. So this is a method on JavaScript arrays that's available to you. And like to know how to use that, you could look up the documentation. So we could look up, so you can actually hover over a filter in VS Code and it'll give you some details typically. Or you can go look it up on like the MDN docs or whatever. But if you look at it in VS Code, the way it's a little tricky to read it because it's showing you some type information that is sort of related to TypeScript. But I'll go ahead and read this out, or at least tell you how I interpret it. So it's telling me that filter is a method, which means like a function on an array. And in this case, because it's like pretty intelligent, it knows that I'm actually calling filter on an array of numbers, because that's what I made. I made an array of numbers. I'm calling filter on it. So it's like you're filtering an array of numbers. So it's just intelligently doing that. It just like it knows the type from looking at the code that I wrote. And then it's saying, okay, filter takes a function, and then which is calling predicate. And here's the signature of the function. And it's saying that function takes 3 parameters: the value, which will be each element in the array, which will be a number in this case, and then the index, which is like the position in the array. So if for some reason your filtering logic needs to know like what position in the array it is, you can have that as a parameter. And then it actually passes you the entire array as the 3rd parameter, which is kind of interesting. Most of the time when you're using filter though, you typically only care about the 1st parameter. And so that's why you'll see most of the time when someone's doing filter, they just take the 1st parameter. And often you'll see people use like 1 letter for the parameter. Often that is like, in this case, I'm thinking of number basically, but like, it's also okay. Like, so since we're doing it on numbers, you could also have said, like, you'll often see people that are trying to be a little bit more verbose will say like number. So I'm going to filter numbers, and then my filter, with the function I passed to filter the 1st parameter, I'm going to call number because it's going to be each number in the array. And then so predicate's a function that can take those 3 parameters, and then it needs to return yeah, that's a little funky. I don't know why it says unknown there. Maybe it's just because I haven't implemented it yet. It's like confused. So I'm just going to hard code true right now. See what yeah, that's interesting. I don't know why it says unknown. That's not very helpful. But does anybody know the type you're supposed to return from your filter predicate function? Like, are you supposed to return a number or a string or a Boolean or what?
Number.
Sorry, not the, sorry, that was a confusing question actually. So the entire thing, so there's like so there's this whole thing that's going to return something that I'm going to then assign to the even numbers constant. But the function that I'm passing it, that is supposed to, for each element, that function is supposed to decide whether or not to keep it in the array. So it's sort of what, so like filter is saying, hey, you've got this array of elements, and you only want a subset of it. Like, you don't want all of them in there because you want to filter some out. And so it's like, okay, great. Like, I'm the filter method. I make it easier to filter. You just need to tell me what you want. Like, so give me a function that tells me what I should keep in the array. And so like, how do we say yes or no? Like, here's this element. Do you want me to keep it? So
So
what
like a Boolean.
Boolean? Yeah. So we basically just say, hey, keep this one, throw that one out, throw that one out, keep this one. And we just have to decide like what logic we want for that. So I want the even numbers. So we need to say, hey, hey, for this element, if it's even, keep it. Otherwise, get rid of it. So, and if you would, I think if you probably read, if you read this, it's a little bit more helpful. So a function that accepts up to 3 arguments, and we covered what those 3 arguments could be. The filter method calls the predicate function 1 time for each element in the array. And then it really would be helpful if it said, and that predicate function should return true or false for whether or not to keep it. And I think if we looked up the docs on MDN, you would see that. None of these are the filter. Okay. So this isn't the method we want, but here's the docs for array. And then I should be able to scroll down to oh, I'm on string. What the heck? Why would that be the result? MDN array methods and it gives me string. Okay. All right, so here's the filter method, and yeah, creates a new array with all the elements that pass the test implemented by the provided function. And then here we go. Function is a predicate to test each element of the array. Return a value that coerces to true to keep the element or false otherwise. So yeah, we need to return something that's either truthy or falsy. And I think we've discussed a little bit about the notion of truthy or falsy, but like really you should just think of it as returning a Boolean. That's what you want to do. So yeah, so it's pretty simple. So we say, okay, number, and then we need to decide if it's true or if it's even or not. Does anybody know how to do that?
Modulus.
Yeah, number modulus, and I feel like
Mod 2 and equals the 3 equal signs to 0.
So I don't think this is modulus. It's called remainder. I don't know if
So if
JavaScript.
the remainder of the division of 2 of the number is 0, then it would be even.
Yeah, you're right. I'm just sorry. I think there's like technically modulus, I think is like slightly different.
Right.
But let's not worry about that right now. So yeah, so remainder, so number remainder 2. And then we ask if that is 0. So it divided by 2, and if there's no remainder, then that's even, is what this is saying. So yeah, if we did, so we do 2 modulus 2, there is no remainder. We do 4 modulus 2, there is no remainder. But if we do 3, or sorry, remainder 2, there is a remainder of 1. And so that's how you can find out if something's even or odd, or that's one way of doing it. And so we just ask, okay, so if we divide the number by 2, does it have a remainder or not? And so this will be true for evens and false for odds. And so yeah, that should do it. Yeah, so then we can see log to the console is a new array. So we didn't like modify the array or anything like that. Like numbers is still there. Here's our full list of numbers, and then even numbers is a new array with just the even numbers. So we're gonna get into a ton of these methods. Like there's a ton of array methods, filter and map and reduce and find and all these different methods. And we're gonna get into them a lot for Wednesday's class. But they're just like really great ways to do stuff you would like. What's the other way we could have done this? Like if we didn't have the filter method and we wanted to have a new array of even numbers, and I was like, you can't use filter, so go ahead and do it. Like, what would you guys try to do?
A loop, like a for loop.
Yeah, exactly. Yeah. So like anything you can do, like any sort of like problem, like most of these like algorithm scripting problems that you guys are doing, like you could always just do a for loop and solve them. And so like we could easily have solved this with a for loop as well, but it's just like not as clean. And there's like a lot of typing and stuff you have to do. So if we did it without filter, we would have said like for, var I equals 0, I less than numbers dot length I plus plus, and then we do, numbers I modulo 2 equals 0, and say like, if that is even, and then we'd say like const non filter even numbers. We like initialize an initial array, and then if it's even, we would like push to it. And then we'd be able to console log our non-filter even numbers. So you can see like we had the same answer. Sorry, I did that pretty quick, so I'll pull it up for just a second. But like here's the way that at least I would have, like one way of doing that problem with a for loop. But like this looks awful. It just looks terrible, and like this looks really good. And so there's like, you can solve anything with a for loop that needs looping, but like there's like programmers don't like writing code that looks like this. They want, and like they don't want to write it's like verbose writing a for loop. And so there's all these methods that have been added to the array in JavaScript that cover like very common use cases. So filter and map and reduce and find are just like a few of the methods like I use all the time. Okay, so that's that. Any questions on that? Okay, cool. All right, so we're gonna do some high level stuff today. And I'm gonna pull up this whiteboard. And I think anybody can edit this right now. So don't do anything inappropriate, but feel free, if anybody's artsy, to like, as we whiteboard stuff, like feel free to make it look better if you want to. But I want to go over the, like, all the topics that we've like brought up very quickly in this module so far. And we've kind of, like everybody seems to be struggling with this module. And I think like on the one hand, like that's actually the case every time like since we've been doing the bootcamp in this format, like this has always been kind of one of the harder classes. And it's just like there's like a ton of stuff that you have to kind of take in all at once to kind of take this next step in the journey. And so hopefully though, like we're past that pain, and hopefully after today it'll seem a little bit more clear, and there'll be like a collective exhale. Or maybe a collective inhale and exhale. But so I want to go over at high level all those topics, and hopefully you'll kind of see how it all connects. And what's really cool is like you'll have this like great foundation upon which the next module where we do React, and then the final module where we do some database and server stuff, like those will feel a lot, like those modules will be, like if you get through this one, those ones won't be, they're still hard, but they're like, there's not like a whole boatload of new concepts you need to learn, or anything like that. So in terms of like just infrastructure and like how the web works and stuff like that, like with the React module, it's like, hey, remember how we were doing all this document.get element by ID and like doing all this weird stuff to like inject JavaScript stuff into the browser? Like it was kind of nasty. Like React is just a way better way to do that. And that's like all it is. And then the backend class is just, you know, hey, you've seen how you can pull JSON from an API. So like like the weather API that we've been playing with, like you've seen that, you know, about how like there's stuff called servers and there's stuff called APIs where you can hit a URL and it'll give you back data in JSON. And then that class is just like, well, how do you build that? And that's all the final module is. So anyways, I'll start actually whiteboarding stuff now. So all right, so we've discussed this notion of a server. And whenever you hear that word, there's like probably quite a few things you may think of. So I don't know if I can make this smaller. So when I hear the word server, I think of API. I think of like, you guys have probably heard the term like AWS or Google Cloud Platform, GCP, or Azure, Microsoft Azure. And I think of like JSON, and I think of like reading and writing data. So those are some of the concepts for me that come up when I think of server. Or you'd think of like a massive like data farm, right? Like that's like a server farm. And so that's one big massive piece of the web, which is computers that are dedicated to just serving content to you. And a lot of them take the form of just serving data, like JSON data. So like when you go to a website, like remember when we were looking at New York Times, like there's a server that gives us the HTML for this page. Am I sharing? I'm not sharing my screen. You guys can see the whiteboard though, right?
Yes.
Yeah, okay. Yeah, I'm just gonna close it for just a second. So like we go to this New York Times website or any website, and there's a server somewhere that gives us the HTML in one request. But then typically what happens is then the browser loads that HTML and there's JavaScript that loads. And then that JavaScript immediately then makes a request to the server again for the data that it should show. And it gets that data in JSON. And then it like loops through it and adds it to the website. And you can watch all the requests to the server through the network tab. So like whenever if I refresh again, you can see all these different requests that go to the server. And then if I like click on something, you can see it sent another request to pull more data. And then I'll clear this so you can see it again. And then if I click on something else, like a detail page, it then makes, I made a bunch of requests, and then makes a bunch of requests again to pull all the data related to that detail page so it can show me all this content, right? So that's one big piece of the web is, let me pull up the whiteboard again. That's one big piece of the web, which is servers. And, you know, they're not like your laptop. They're like, you know, like they don't have like a screen or anything. They're just like hyper tuned to just be like, you know, a RAM and a hard drive and a CPU. And like you deploy your code to those things, and then it just runs your code and listens for requests on the internet. So that's a server. Now, as a programmer, you have a laptop, right? So you're on a laptop, and as a programmer, that laptop will act in different ways depending on like what you're working on. So when I'm coding, the context that my laptop might be in can, let me, it can act as a server, or it can act as a browser, you know, or it can act as a phone. And yeah, so as a programmer, you'll like run a program on your laptop, and that program would be like a program that you would typically run on a server. So your laptop will be acting like a server, and you can then have your laptop act like a browser and visit the page that your server is listening on. So like whenever we, I wish I could share my screen and the whiteboard at the same time. Whenever we are in VS Code and we like wrote this, like, so for the warm up, I wrote this HTML and then I wrote this JavaScript. So like, I know the context of this code is going to be in the browser. And so whenever I want to like test the code, we typically start this live server thing, right? And what is happening is that we're actually in VS Code, this extension is starting a server. And then that server is listening on your computer. And whenever you run a server on your computer and you want to talk to it, you talk to it through localhost. So that's just a special URL that whenever you go to it, it's just like, don't go to the internet and request this, just talk to the computer. And so we go live and you can see it say, hey, I'm listening on port 5500. And so typically, whenever you're on the internet, you're always going to either port 443, which is the HTTPS port, or port 80 if you're not on HTTPS. But you never see that. Like you never see the port on whenever you go to like a normal website. But you can see that that's happening here. And so the IP address 127.0.0.1 is technically the IP address of localhost, but localhost is just like a it's like a domain name almost. Like, so normally whenever you go to a website, you go to like pitchfork.com or NewYorkTimes.com, but that domain name like has to look up an IP address and then go to it. So that's sort of like localhost is kind of doing the same thing, where it knows that I mean 127.0.0.1. So you can see like this is the same page that I was on just a second ago. So this is I'm in a browser and I'm saying go to this address, and then my computer is running a server that whenever I hit that address, it responds with whatever live server dictates it should respond with, which in this case, if it's not a file, it gives me this like folder structure thing that I can go through. But whenever we get to an actual file, it then sends me that HTML, and then my browser interprets that HTML. So So when I think of browser, I think the words I think of are like client, or like phone, or user, or like HTML, CSS, and JS. And I also think of like web apps. So there's like, if you're a web programmer, which is what we're teaching, and web programming is like the most popular form of programming, just because like websites are so ubiquitous. Then you're typically programming for one of two spots. You're either programming for stuff in the browser, or you're programming for stuff that's going to run on a server. And so in the browser, you can write like a ton of JavaScript stuff, but it's all going to be in the context of running on the browser. So like on a web page, like changing forms, or like looping through data to display cards. It's all typically, all the JavaScript is typically around either getting data and then displaying it, or taking information from the user and sending it to a server to save. So we like, so far in the whole OK Coders track, most of the stuff we've been talking about has been related to the browser, but there's this whole other piece as a web programmer, which is the server. And the server is like, that's like whenever you're programming for stuff on the server, that's where, if you're a JavaScript programmer, you're using Node, and you're using, your terminal and stuff. So yeah, so there's these two large concepts, server and browser, that are out there. And then your laptop can like act as either one, right? So your laptop context can be, depending on the problem you're working on, can be, you're doing stuff for the server, or it can be, oh, you're doing stuff for the browser. Okay, any questions so far? Okay. All right, so there's those two concepts, server, browser, and they talk to each other, right? So like they're separate, but they have to communicate with each other. And so the way that communication happens on the internet is, really incredible. And like you could spend your whole career learning about how internet communication works. But sorry. It sounds like the guys are getting in the hot tub. You're good. So whenever we go to the browser and we put in a URL, our browser is then making a request on the internet to some server somewhere. And the way that communication happens is through typically HTTP. So you'll always see on any URL like HTTPS or HTTP, which is a hypertext transfer protocol. And so that's just how that's like a big piece of the infrastructure for how we communicate between like a browser and a server on the internet. So HTTP or HTTPS, and HTTPS just means secure. So like the information's encrypted, so that if anyone like sees the traffic, they wouldn't be able to understand what information you're sending. So we talked through HTTPS, and whenever we're sending data between a browser and a server, like it can only be in a certain format, and like it basically is like a string. Like you can think of it, it's not a string. Like it gets turned into like zeros and ones and stuff. But you can think of it as like, if you're going to send something over the internet, it's going to have to be essentially a string. And so like whenever you go to a website, it responds with a giant string of HTML, and then your browser like interprets that string and then it creates the page. And so you have to send information over the internet as a string, and so that's typically going to be like HTML and CSS, and like your JavaScript program is just a string. And then when we want to send, so that's, when we want to send a program, we just send like the code, right? Just a string of all the code. But when we want to send like just data, so like, you send, like if you go to Facebook or whatever, all the code of Facebook goes to your browser and is loaded, but then it's like, okay, well, like give me the user's posts, or like give me what I should show them. And so whenever we get data over the internet, that is typically JSON. And we learned a little bit about JSON, which is just like, it's a string, but it's like of like how we are able to store data in JavaScript, which we've seen is like either like an array of objects or like just one big object. Okay, and then the way that you decide like what information you want to get, or like where you want to go on the internet, is through URLs. And we've heard this concept of RESTful URLs. So you as the programmer working on the server, working on the API, you decide what URLs you want your program to respond to. So if we decide to start making a to-do app or whatever, and we're setting up the server for that, and we need to send the browser their current to-dos, like the URL of that might be like we might buy the domain of todo.com. So we bought that domain. So we can deploy. Oh, sorry. So we bought that domain, and so we can deploy our code to a server, and then we buy the domain. And so the domain name registry will say, hey, if anyone goes to todo.com, we'll send them to your server and you can respond. And so we buy that, and then we just need to decide like what URLs we want to use. And so if someone is going to get their to-dos, it might be like /to-dos or something, but we get to decide. It's up to us, because like we're going to write the server code and the browser code, and so we get to decide. We just have to communicate either between the teams, if there's like a front end team and a back end team, or if you're a full stack engineer, like you just get to decide yourself. So I would like set up the server. I'd say, okay, I'm going to go to /to-dos to get my full list of to-dos, and then I'm going to start writing the browser code. And so whenever I do my fetch to talk to the API, it's just going to be todo.com /to-dos. And I know that I'm going to get back a JSON array of objects that are all my to-dos. So this is like the URL. And so since like you can just make any URL you want, we try to have like standards, or have a convention for like the way that we do them. And RESTful is just a convention for how you go about deciding what URLs to use for stuff. And like, honestly, it's just like, since you guys have used the internet so much and you've like seen URLs so much, you're probably already kind of into it, like what the format is. Like slash to-dos is going to give you like a list of to-dos, and then if there was like one specific to-do that you wanted, it would be like to-dos slash the ID of the to-do. So like it might be like 1 or 2, or it might be like some kind of like identification kind of hash, which would be like this kind of gibberish kind of string like that, which is like an ID in certain cases. So yeah, RESTful is just, you can learn more about RESTful, but you don't need to worry about it right now though. It's just the convention of like how to make URLs that are kind of standard. All right, what else do I want to put on here? Any questions so far? Okay. So I think everyone has been okay with doing stuff in the browser so far. So as a programmer, if you only are going to do front end code only, then most of your work will be done with just like your code editor, VS Code. And then like if that's all you're doing is just front end stuff, then you would just have like, you would use Live Server to, that's the extension we use to basically, like after you've made some HTML and CSS and JavaScript, like that's, you guys have all used that extension to essentially say, hey, like open this in the browser. But I just kind of walked through and showed you guys, like when you open something in the browser is like going to send a request somewhere, and there has to be a server listening to give back data. And so like you write your HTML, your CSS, and your JavaScript in VS Code, and then that extension is just making it really easy for you to spin up a server that your browser can then talk to get that data that you just created in the code you just created. So you're mainly working in VS Code and Live Server, and then you're just like opening your browser and doing stuff in your browser. So that's sort of the tools that you use is just a pure front end engineer. And then you would use like GitHub and stuff like that to push your code so that other people can use it. We started showing you guys a little bit of what the environment is like if you're doing more backend programming, if you're doing more server stuff. And it's like a totally different environment, right? And it's a little bit harder to get set up and like get used to. And the environment for programming for the server is like the command line or the terminal and VS Code still, but then you're writing JavaScript only. So no HTML or CSS, you're just writing JavaScript. And then you are running your JavaScript in a program called Node. So normally, like on the front end, when we run our JavaScript, it's the browser that's reading it and interpreting it, and it's then the browser-based JavaScript interpreter. But if you're doing stuff for the server, like we're not running it in the browser on the server, we're running it on like some server farm, or we're running it on our laptop before we deploy it to that server farm. And that is done with Node. And so Node is a program that you run from the command line. So like to be able to run Node, we open our command line, and the command line is, the awesome, cool, nerdy looking way that you can talk to your computer. That's not using like GUIs. So graphical user interfaces are what you're most used to, which is like clicking on stuff and buttons and everything. But the command line is how you can like talk to your computer and do stuff to your computer just through text. And most of the programs that backend developers run are only available to run through the command line. There's no like GUI for it. And so like, there's just like a bunch of tools and stuff that are only available to you through the command line. And that's why you have to learn it. And one of the programs that you would use as a JavaScript backend programmer is Node. And so that's a command that I'm sending to the terminal, and it's saying, hey, find the program called Node and run that program. And so when I just run Node by itself, the terminal changes from listening to like my OS commands and stuff like that, which is like, you know, move around the computer, like move to this directory, or like make this file, or delete this file, or make this folder. It changes context from listening to like OS type commands to listening to now just JavaScript. Like now this thing is running and it's got this caret and it's waiting for JavaScript commands. And so this is like on my computer, this is a program, and the only use of this program is for interpreting JavaScript. It's not going to interpret HTML. It's not going to interpret CSS. It's just going to interpret JavaScript. But since I'm running Node on my computer, like I'm not running it in the browser, I'm running it on my computer, I can do stuff with JavaScript to the computer. Like I can make files, or I can listen to the internet. Like I can wait for requests from the internet with Node. And like I can talk to a database and stuff like that. So like, just like when you run JavaScript in the browser, you have access to browser stuff. Like in the browser, you can access the DOM and change the HTML and the CSS on the page. Or you can make a request to the internet in the browser with the Fetch API. And like you can do stuff in the browser. Like since we're running JavaScript through Node on our computer, we can do stuff to the computer. And so that's why like you learn one programming language, but the like context it's running in then gives you access to different tools and like different things you can do. So yeah, I'm running Node right now, so I can do JavaScript stuff, and then I can exit Node by doing Control-C twice. And now I'm back to my computer, and I can do like, you know, what directory am I in? I'm in so like normally you guys are used to using Finder, right? So I just like opened Finder, and it's my file explorer, and I navigated to this curriculum folder inside the OKCoders folder. And so like right now I've clicked on curriculum. So my present working directory is this curriculum directory, which is at, you know, my user /code/OKCoders/curriculum. And so on the command line, that's where I am as well. I'm at, if I ask for my present working directory, it says you're at users, Zach, code, OKCoders, curriculum. And then in the GUI, it's automatically listing to me all the stuff that's inside the curriculum folder. So I can see, you know, there's a couple MD files, and then there's these folders. So from the command line, I can do the same thing. I can say, hey, what is in this folder with ls? And you can see it's listing out that same stuff that I could see from this GUI. And then I can, you know, move, so change directory to module 3, which is the same, like that was the equivalent action on the command line as just clicking here, right? So I moved to module 3 and then it listed what's in there. And so I can do that same thing again. I can list what's in module 3 and then move again to day 7. And then I can list, oh wait, I want to go to day 6. So what I did, so I like moved into the wrong directory. So I wanted to go up 1. So going up, you can do cd ... that means go up 1. And then I moved into day 6. So now my present working directory is day 6 of this whole tree here. And then I can list what's in there. And there's this warmup.js file. So most of the time you don't run node by just typing node and going into node. Most of the time you give it a file to run that has JavaScript code in it. And so in the context of a server, typically that means like you've written a bunch of code to respond to the internet whenever people request data. And so you have like, you wrote a bunch of JavaScript code. And one of the things it does is if someone goes to /todos, the /todos URL, then you're going to get some data from the database and then turn it into JSON and then send that JSON data back to them. And so you would have like you'd have like a bunch of code written that does that. And then you would run it with Node to test it. And then you send that code to a server and then it would run that code with Node and just let it run. It would just run until you kill it. So typically you've got, when you have deploy code, it like runs for like days until you decide to update it again, basically. So typically we're giving a file, like an entry point into a program that then just like listens for requests from the internet. And so like I wrote this warmup.js file with the context of it being run in the browser, but there's nothing that I wrote in it that is browser specific. If we look at it, like all I do is just pure JavaScript stuff, which is, an array and then filter and then for loop. And then it just so happens that to log in the browser is in the terminal in the browser, like the JavaScript terminal in the browser is the same exact syntax to log to the command line, like just like screen, right? So that also, even though that's kind of different, it's going to work. This code is going to work either in the browser or in Node.
Is that?
Yeah.
Are you sharing another screen? Because I can only see the command line interface.
Oh crap. Okay, you couldn't see VS Code?
No.
What do you see now?
Now I can see VS Code.
Okay, I was just referring to this program, the warm-up program. So like all the code in here is, so far we haven't written anything specific to either the browser or to the Node context. So I can run that program with Node. So I'm going to do Node, and then you typically pass a file name to Node to run. So I'm going to give it warmup.js, and then so we can run that program with Node. That program doesn't have anything that keeps it from stopping. Like there's nothing that like says like, oh, sorry, my throat's all dry. There's nothing in the program that we wrote that's like, loop forever and wait for someone to talk to you on the internet. So if you don't have anything in your code that says like keep running, then Node will just run the code and then quit. And so that's what happened. We said Node, run this file. It ran the file and it was like, okay, I'm done. And then it just exits. And so now we're back to the browser context after running that program. Or sorry, should I say the browser context? We're back to the OS context. Like we're back to the command line. Okay. Let's see if there's anything else I wanted to talk about. Yes, okay. All right, so, no, I don't want to draw. All right, you see the whiteboard now?
Yeah.
Okay, so most of the code that we've written, so just think about the browser code, is synchronous code, meaning like the code is running and it just like does the line that we said to do immediately. Like the code, like, so it's running through the code and it just like does each action synchronously and like doesn't do any waiting or anything like that. It just runs it as fast as it can. Whenever we want to talk with something else outside of the context of our program, that can't happen synchronously anymore. So like if we're writing our code in the browser and we say, okay, hey, now like let's go get some information from the internet, like let's go get the current weather, that can't happen immediately, right? Like we don't have control over that. We have to like literally talk to the internet. Like we have to send a request to the internet. It's got to go through the tubes, and then another server somewhere has to get that request, do its thing, and then respond and send the information back to you. And so like that's what's called asynchronous code, meaning like you've decided to do something in your code, but you have to wait and you don't know how long it's going to take. And so we have to write, like whenever we get to a scenario like that, where we're talking to the internet, or we're, you know, like writing a file to our computer, or we're like, it's almost always talking to the internet. But whenever you do an action like that in your code, we have to write our code a little bit differently so that it's asynchronous. And the way that you typically write asynchronous code in JavaScript is with promises. So promises is this like interface or like API in JavaScript to be able to write code that's asynchronous. And we saw that for the first time with the weather project that we've been doing. So that project, you know, like has some synchronous code where it's like, you know, getting loaded up in the browser and we run a few things, but then very quickly we say, hey, go talk to this API over the internet. And so we have to do it with a promise, like, because whenever we call, so yeah, we had this is what Devin did on Wednesday. So we had this HTML file, it loads the HTML. So it starts loading the HTML, then it immediately loads this script, and then it runs that script, and then it finishes this HTML stuff. It makes this button. So here's our JavaScript though. So we put our API key in there. We put the URL that we want to talk to in there. And then we say, hey, once the page is done loading, because we need to wait for that button to be created, then run this function. And here's the function. And like most of this code here is synchronous. But then once we say, hey, well, actually, I mean, if you think about it, like the event listener click is sort of like an example of asynchronous code as well, because it's like the program runs and then it's sort of like waiting and listening for something, which is someone to click. And that's why we have to say, like, that's why we always had to do that format where we gave it a function, which is like, hey, whenever they click, run this function. So we pass this function to that click listener. And then whenever we say, hey, we're going to use fetch and go fetch at this endpoint. So that's like, this is like an amazingly simple way to say, like, go talk to the internet and go talk to this URL on the internet. Like that, this one line of code is doing an amazing amount of stuff, which is like, here's the URL, make an HTTP request to it, wait for a response, and then, you know, whenever you get the response back, then let me know, because I want to do stuff with that. So since that's what we're doing, since whenever we say, you know, run fetch to this URL, since that's asynchronous, since it has to go talk to the internet, what this gives back to you, if you hover over fetch and look at it. So this, we were looking at the signature of filter at the beginning of class. So fetch is a function that takes this input, which is request info, which in this case is just, we're just giving it a URL. But so these are the parameters it can take. This here, whenever you see this, like whenever you see the function close like this, and then there's this colon, it's saying, it's now like after the colon, it's telling you what the function returns to you. So like, what does it give back to you when you run the function? What's the return value of the function? The return of the function is a promise with what of a response. So it's promising that it's going to give you a response from the internet, is what this is sort of saying. This is, you may not have seen this syntax may be a little confusing to you. This is the syntax for basically like a type wrapping another type, so that like the response is like a type inside of a promise, sort of, is what this is kind of saying. So yeah, we're getting back a promise of a response from the internet. And so we cannot just do like const data equals fetch, like, because the way that we work with promises is we have to do this dot then stuff, which is how you do asynchronous code in JavaScript. Hey there, we're great. Yeah, I'm doing a class right now. Yeah. I'm like thrilled to be doing class today. That sounded like I'm kidding. I've been missing teaching you guys, so I'm happy to see you guys again. So the way that we have to work with a promise in JavaScript is through the promise API, and the promise API, the way it's defined is you have to do this like dot then kind of chaining thing. When I say chaining, I mean this like kind of weird syntax where you do like dot then dot catch. That's like this kind of, it's called like method chaining, where you do like dot something dot something dot something. And what we're essentially saying is like, hey, go talk to the internet, get their response. Whenever you get once you get the response, then pull the JSON from the response, then take the data from the JSON and log it to the console and call this function and call this function. If for some reason that fails, so think about this, like talking to the internet might not work. You know, like this server that you're trying, like you're saying, go to this URL, and it's like, okay, I'll see what's at that URL. And like, maybe there's nothing running at that URL, or maybe it's a junk URL that you typed in that doesn't exist. Or like you broke the prod server and it's not listening on the internet anymore. And so you have to handle that failure case too. And so we dot then is like if it works, but there's a dot catch, which means if it failed. And if it fails, it's going to give you an error object, which is like a description of what went wrong. And that error object has a message property, which is just like a string description of what failed. So yeah, the promise API in its raw form has this format of fetch. Well, sorry, fetch is just something that returns a promise. There's many things that can return a promise. So like anything that's asynchronous will return a promise to you. And fetch is just one of those things that returns a promise. But whenever you're working with a promise, you use this dot then syntax, this dot then dot catch. That syntax is kind of hairy. Like it's sort of like, it's not very pretty. It's kind of like when I was complaining about this for loop, and I'm like, no one likes writing code like this. So like, that's why we have filter. The same kind of thing happened with promise. Like everyone's like, this sucks, this like dot then crap. And so async await was added to the language to be a cleaner way to work with promises. And so Devin showed you guys that syntax down here, which is like, you can do fetch. Oh, he did this wrong. Okay, so well, okay, I think he was just showing this really quickly, so I want to make sure we get the right syntax though. So we're gonna, so the way that you would with async await, if you want to use async await instead of using the promise old style, what you do is you have to write an async function. So we're gonna write like so we do async function get weather data. So like, you write a function synchronously by just saying function, but if you want your function to do something asynchronously, and you want to use the async await syntax, you just put async in front of the function. That's all you do. So we're saying, hey, this is going to be an asynchronous function. And so what that means is I can use await inside this function. So we can do, I guess I should, let me copy this to today so we preserve what he did. Okay. So I'm making, I'm going to make a function that, does my fetch of the weather data, does my talk to the internet thing. And then whenever we get the data back, we're then going to like call a function that's going to update the page and inject our data into the page. So get weather data. So we want to talk to that URL that is in that. So we put that forecast endpoint there. Oh, it looks like he put the key here, but didn't actually use it. So let me fix that. Okay. Okay. I'll go over this whole thing in just a second. I was just kind of cleaning up some stuff. All right, let's see if, let me just see if this is working real quick. That's so small. Why is that so small? Okay, cool. It looks like it's working. All right, so I'm clicking the button. It's then kicking off that code that talks to the internet, and then I'm logging the data we're getting back. And so we're getting back real-time weather data, which is really cool. Like, that's pretty cool. So here's the current conditions. So it's last updated at 10 a.m. today. And it feels like 55, apparently. I don't know how this knows where I am. Is it giving me like, is that in the query? Yeah, that must be some sort of location thing. Bethany, that's in Bethany. So, okay, so notice that, like, you know how we were looking at the network tab whenever we were on New York Times and we saw those requests happening? So whenever I load this page and click this button, you can see my request happening in the network tab, just like you can on any other website. And you can see, like, here's the request. It responded with status code 200, which means success. So 200 okay is the success status message whenever you talk on the internet. And we can then look at what the response was, or we can do preview as well. And so this is the raw response, and preview is like the response formatted nicely. But you can see, yeah, here's like the JSON that we're getting back. So yeah, this is pretty cool. So I changed what he had done in the previous class with the promise.then. I changed it to use the kind of newer, cleaner syntax async await. And it makes it so it looks like you're writing it synchronously in line. Because, like, we have this function and we're saying, like, fetch at this endpoint, like, go talk to the internet. But it's like, it seems like immediately we're assigning the data that we get back to a variable. Oh, why isn't response assigned? Okay. Okay, so yeah, it looks like, it almost looks like we're writing asynchronous code, but what we're doing is we're using this await key, and that's doing what it sounds like. We're saying, hey, go talk to the internet, await the response from the internet, and then assign that to response. And then that response thing though is still like a promise. And so we have to do this, or sorry, it's not. So sorry, that was confusing. So this is the response. It's not a promise. Like, because we used await, we remember how when we were doing here, we were looking at what fetch responds with, and it says a promise of response, like this sort of wrapped thing. When we use async await and we say, hey, await, it's sort of unwrapping the promise. And so we get back, if you look at the type here, it's not promise of response, it's the unwrapped response. It's just the response. So that's like the magic of what await will do for you. And so we then call response.json. That doing that, asking for the JSON, is asynchronous as well, which actually seems a little odd. And it is a little bit odd. I don't know why the fetch API does that. But essentially, when you call this, you can see it returns a promise of what's called any, the any type. And because it has no idea what the internet's going to give you. Yes. Like when you talk to the internet and you go to the server and you ask for data, it decides what it gives back to you. You have no idea what it's going to get back to you. So this is saying like, hey, you're going to go talk to the internet and it's going to give you something. I don't know what it's going to be. But it is going to be a JSON payload. It just doesn't know like what's going to be inside of it. So we await that too. And so then we get data, and that is any. It's not promise of any, it's any, since we awaited it. So then we can just console log data right here and see the JSON payload we got back from making that request. And so, yeah, so like, don't you think this is a little bit cleaner than the promise, .then style? And so people typically write asynchronous code like this with async await. But remember, it may fail. So it may not work talking to the internet. And so there is no .catch in this style. And so you wrap it in what's called a try catch block, which this is a JavaScript thing that we haven't taught you yet, but basically you say, hey, try running the code in these curlies, and if anything goes wrong, if it throws an error or fails, catch it, and then I'm going to do something if that happens. And so in our case, the do something if that happens is just log the error. But normally, like if you think about what happens on a website, if you like try to submit a form or something like that and it fails for some reason, they had like a try catch block, which was like, hey, try to talk to this server and send it the data from the form, but then catch it if it fails. If it fails, like we'll get like show a toast notification that's like, hey, error, we couldn't talk to the blah blah blah, here's why. So that's typically what you would do in a catch block, is just like display the error to the user or something. So yeah, so the code of this program, like it's not a ton of code. We store the URL we want to talk to on the internet. We wait for the page to load, and once the page loads, we then run this function that attaches an event listener to that button. So we get that button by ID, and then if we find that button, we then add the event listener of a click. And when they click on it, we want to run this get weather data function. Here's the get weather data function. It's an asynchronous function, and it's going to talk to the internet, get the response, and then get the JSON from the response, and then just log the data. So what you would do here at this point is you'd want to update the page. So like once you get the data, instead of just logging it, you would call another function or just write your code right here to add your data to the page. And so that's what this add data to pre tag is. So we can do add data to pre tag and pass it the data. So it's going to try and get this data results thing. And then right now it's just stringifying it, it looks like. So let's see what this page looks like. Yeah, look at that. Cool. So yeah, I mean, like it all happened pretty fast, right? I mean, this is all talking on my computer, so it's like really, really fast, but the internet's really fast too. So I know it, we say it's like, hey, asynchronous, it's got to do all this stuff. It still happens really fast. So like, yeah, whenever we click this, like that's how fast the internet is. Like it wouldn't talk to this weather API, some server somewhere, and it gave us back the current weather, and then we displayed it on the page, all like in milliseconds. So like this request to this forecast took, you can look at how long it took. It took 1 millisecond. It's just crazy. So, I mean, but like that is like all the stuff that we just went through to get to this point where we've got, you know, the browser, and that browser then talks to a server somewhere and then gets a response and then shows it on the page. Like that is like the internet. Like that's how, like that's like the full scope of what you need to know, just like at a high level to be a full stack web developer. Is like there's servers, there's browsers. I can write code for the browser. I can then write code for the server. You guys can't quite yet, but you'll learn how to in a later module. But you can write code for the server, and then you know how to write code to have them talk to each other. And yeah, it's pretty cool. It's pretty cool. So yeah, any questions? Like, was that, do you guys feel a little bit better? Is there any other stuff that you guys have questions about that you want to talk through now related to this high level stuff?
I think that was really helpful.
Cool, sweet.
Yeah, me too. I feel like I have a better understanding, like the whole picture now.
Awesome. Okay, great. Awesome. Do you guys feel like, I know some of you have been able to do some of this for the weather project. I would, if anyone's working on these projects, I would not worry about the node one right now. Just focus on the weather one. But do you guys feel like better equipped to now, like you can take the code that I just did, right? And you would just start writing new functions that would pull data from this JSON payload to display it on the page. So like if you wanted to, you know, just add the name to the page, like not this whole JSON thing, like you could do data.location.name Bethany, right? Because like so you can look at the response and see like, okay, so there's like, so this is an object, right? So I can access the key location, and I do that by doing dot location, and then that thing is also an object, and it has a key on it, name. So I can do data I got back from the internet dot location dot name to pull out Bethany, and then just add only that to the page, right? So like what you guys want to do now is you can take this code here, if you didn't already have something working, and then all you need to do is start adding functions to update the page and inject the data that you want into the page. So hopefully anybody that wants to do the weather project, hopefully you now feel like you have like the tools to be able to work on that. Okay. Oh, was I not sharing my screen again?
No.
Dang it. Yeah, so like what I did was, so remember, whenever we have our get weather data function that gets the data back, we then pass the data to this function. So this function is receiving the whole payload, the whole object of all the weather information. And so like all you need to do for your project is like, it can be all in this one function, but you just want to like add some stuff to the HTML that you can then grab and then like add the data that you want. So to put just the location name on the page, there's in the payload, there's like, you can look in the network tag tab, you can look at the payload, or you can just console log the whole payload. But like we get an object and then that has a key called location on it. And then that location key is the value of it is just another object that then has this name property on it, which is the location I'm getting the weather for. So if we just want to put that on the page, you just have to parse the data payload that you got back. So you just do data.location.name is going to pull that key out of that object inside that object. So get the location object and then get the name key on that object. And so instead of putting the whole JSON payload on the screen, I'm just going to add the name to the inner text of that pre-tag. And so that's what you can see here. I'm putting Bethany on the page. So like you guys would just want to make like a pretty page and then inject like, here's the location and like, here's the temperature and what you know, whatever else you want to display on the page. So yeah, hopefully also I'll push this code up and then I'm hoping that you guys will feel good about, you know, injecting that page with real data.
Yeah, that really helps.
Great. Okay. All right. Any other questions? I mean, yeah, anything else I can clear up that's confusing? All right, cool. Okay. Well, thank you guys. Devin will be teaching on Wednesday and it's going to be much more about JavaScript stuff. So you guys are going to be kind of playing with some of the methods that are on arrays like find and filter and map, and learning a little bit about a concept called functional programming, which is just like a style of programming. So it's going to be just heavy JavaScript stuff on Wednesday. And then I'll be teaching the last class on Saturday, next Saturday. And we can just keep working on, well, at that point, actually, I think I'd like to go back to Node and show you guys the project that I gave you guys for Node. All right, cool. Well, you all have a great weekend. And I'll see you guys next Saturday.
Thanks, Zach.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye.